here, so if we can get everyone to take their seats, etc. And there we have the lights. Beautiful. I love automation. This one I'd like to introduce Alex Sutton. He's another one of our program managers, and he's going to be talking with you this afternoon about the monitoring and event capabilities within the product. So, okay. Alex, take it away.
Thanks, Bob. As Bob said, my name is Alex Sutton. I am the program manager for the monitoring feature area on AppCenter. Before coming to the AppCenter team, I worked on IIS for about 3 years. Before coming to Microsoft, among other things, I ran a bunch of web servers for a newspaper in San Jose. So when I came to the AppCenter team last summer, and we were designing the features, one of the most important things to me was that the plumbing work. That the system was instrumented, and more importantly, that it was very extensible and very customizable. Over the past few months, we were very heads down in the development, and so to prepare for this talk, I finally had some time to spend really playing with the product, playing with the plumbing, and I was just blown away. All of the eventing, the power, the customization, the scripting, the way you can get at all this information is really, really cool. So hopefully over the next hour or so, and then once you have a chance to play with the product, hopefully you'll agree that beauty is in the plumbing, is in the details. There are three main areas in the monitoring feature group. The first is of eventing system information that we generate, and here we'll talk about WMI, application center events, performance counters that we log, and health monitoring. Second, we'll talk about once the events are generated, how do we store them. We'll talk about the AppCenter log, how we use the Windows log, and alternatives. And then finally, once the events are generated and stored, what do you do with them? How do you use them? How do you see them? We'll talk about a little more detail on the AppCenter UI, health monitoring, and extensibility. And we'll have some time at the end for questions. So let's jump right into the eventing area. So the first main point is that AppCenter is really built around WMI. We use WMI for all of our core services to fire events. We use WMI to log the events. We use WMI for health monitoring. And one of the reasons we're using it is it's become the Windows standard. And WMI is Windows Management Instrumentation. It's based upon an industry standard from the DMTF, or Desktop Management Task Force, built around the SIM standard, Common Information Model. And it's also a gold logo requirement going forward for server apps. So what is WMI? Well, their primary goal is to make Windows the most manageable operating system. It's to provide a complete infrastructure for instrumenting the system, hardware, applications, generating of events, configuration. It's providing a standard schema, standard query, standards methods for getting to the data, standard format for events, and a consistent protocol for getting to that information. Right now, we do it all through COM, but through the DMTF, they're moving to XML over HTTP. So even how you get to the information is becoming standard. And essentially, WMI acts as a broker between providers and consumers. Providers that have configuration, that fire events. Consumers that look at the configuration, that look at the events. So I basically think of it as management plumbing. So how does it work as this broker between providers and consumers? In the middle is the win management process that has the SIM objects and the repository. Feeding into that are a number of providers, such as a registry provider, the event log provider. On top of that are consumers. How can you view what's in the event log? How can you be notified automatically when a new event comes into the event log? How can you see what registry values are? How do you configure those registry values? There are a number of WMI providers shipping now in Windows 2000, and it's a goal for the next release of Windows to get the rest of the operating system and all the applications, all the services instrumented. Some of the key ones that we use are the Win32 provider, registry provider, the event log provider, performance monitor, and NLB, health monitor. And as you see, all of the applications, all of Microsoft are moving towards WMI. One of the reasons why we like it is it's so easy to use. Here's a sample query where I'm selecting every property from the Win32 logical disk class where free space is less than 2 million bytes. So as you can see, it's a fairly SQL standard syntax with a few extensions to traverse the namespace, to find associations, where classes are derived from, children, parents. And then for events, you can say, show me every event when it happens. Only deliver me events every 30 seconds, every 5 minutes. Group events, so I'm not getting 30, I can get a single event that represents the other events. Only show me events of a certain type. The best way to learn about WMI is to use it. A couple of resources are the Platform SDK has a lot of good information on WMI, and to understand how the namespace works, how the structure is, what information is available. Use a program called WebMTest that is on your Windows 2000 machines, and it's probably on certain NT4 and Windows 98 also. You connect to the namespace that you're looking for. You can traverse all of the classes, all of the instances, register for events, etc. And WMI is also becoming an industry standard for management console. So if you're a potential customer of AppCenter and you're already using Tivoli or OpenView or NetIQ, they're all building WMI consumers, so they can get WMI information and WMI events into their console. And if you're here as representing one of those companies, we want to talk with you also to make sure that you work very well with that AppCenter, are able to consume our events and be able to take appropriate actions. So how do we fire events? The four main services in AppCenter, the cluster service, replication service, monitoring service, and request forwarding service, all have an event schema that we will document for various error, warning, and informational events that respond to different service situations. Each of the server has an instance of our event provider. If the event is an error event, we're going to write it directly to the Windows log for reliability. Just in case there's something else wrong with the system, if WMI is down, we want to make sure that error event is available. Otherwise, all error, warning, and information events are passed on to WMI. If no one is interested in those events, WMI simply drops them. However, if there is a consumer registered, those events get passed on to the consumer. Typical consumers will be the AppCenter logging consumer, health monitor, or any of your tools that simply subscribe to these events. In addition to events, we're also logging performance counters. And we view performance counters as a good way to monitor your server, figure out if something is going wrong. You can view both the current performance and the value of a counter over time. You can view it in our UI or extract the data out to your own database for offline analysis and trend analysis. And the best way to look at this is as a complement to perfmon, not a replacement. So if you see a counter that you're monitoring indicating that something's wrong on the server, you're probably going to want to fire up perfmon, load in all of the counters, and really drill down and figure out what's going on. And the value add that we provide is being able to roll up these performance counters and giving you an aggregate view of all of the servers across the cluster, something that you can't get with Performance Monitor now. As far as configuration goes, it's turned on and off in the UI, and that property is replicated across the cluster. So it's either on or off on every machine. By default, we turn performance logging on at cluster creation. We have a default list of counters that we log. We store that list in WMI. There's no UI for configuring that to remove or add additional counters, but it's configurable through an SDK, and we'll touch on that in a moment. We collect counters every 10 seconds, but to display longer periods of time, like a day, a week in the UI, we roll those values up into longer intervals, 1 minute, 15 minute, 1 hour. And that's to optimize both for space, for query time. So instead, if I'm collecting at 10 seconds and I'm viewing over a week, I'm going to have hundreds of thousands of points. That could be a very large hit on the server when I do the query to view it. So instead, we roll that up to 15 minutes, store only the number of points that we need, and return that to the UI. We'll talk a little bit later about what those specific intervals are. This is the list of the default counters that we're currently working with now. This is not necessarily what will ship in the beta, but what we're thinking about. This list came from talking to various product groups at Microsoft, consultants, customers, and asking, what counters do you watch? What do you think are the most important performance counters to monitor to find out if something's going wrong on your server? So once you see what's in the product, what's in the beta, if you have feedback that we're missing something, that some of these counters just don't make sense, please let us know. And we have pretty good, we're pretty flexible and can make a change before we ship. But just looking at the most common ASP errors, memory errors, physical disk, the iNet info process for IIS, a couple of different views on the processor, both total time, system time, and user time, how much memory our log is taking, context switches, and 3 key counters for the web service or IIS. Extending perf counters, the idea here is to provide you with extensibility. As I said, there's no UI to add or remove, but it's a fairly easy process, and we're working on a resource kit tool to make this easy. So when I say it's easy, is it really easy? Well, the format, since the counter data is stored in WMI, the way you move information into WMI is through a MOF file. So this is the format of the MOF that we use to store performance counter data. You specify the name of the counter. This is both what displays in the UI and is the unique key for that counter. The path to the counter from PDH, which is the performance data helper libraries, how we get the performance data from Windows. The type of the counter, the units that display, that's the text in the UI. How we roll up the counter across the cluster, across the server, and the default scale for the UI. So this is what the MOF would look like in practice. First, connecting to the namespace. I'm creating a new instance of the class ACS capacity counter config. Here I'm going to add a counter memory committed bytes. This is the path. It's the memory object and the committed bytes counter. For this release, counter type is always 1. Units is bytes. This is simply what will be displayed in the UI. Aggregation method is 3. We'll go a little bit. We'll detail a little bit later what the values are for the aggregation methods. And the default scale is 6. This is what you multiply the counter value times 10 to the default scale to scale it down between 0 and 100, which is what's displayed in our UI and in the perfmon UI. This is important to let you see counters of different sizes on the same screen. So, for instance, I'm looking at CPU and available memory. CPU is between 0 and 100. Available memory could be several hundred million. So I multiply by the scale to scale that number down. And just to prove that this is really easy, let's go and give it a try. And let's go to machine 1. So this is a list of the 12 counters that are installed on this machine now. I'm doing it here to also show you how easy WMI scripting is. So if you see the code down the bottom is the code that's generating this page. So it's simply connecting to the SWeb locator object, specifying the namespace that I want to connect to, saying give me every instance of the ACS capacity counter config class, and then for each counter in that counter list, I'm simply printing out name and counter path. Here is the moth that I'm going to add, so I'll add memory committed bytes. Go to a command prompt, and I'll type mothconf to compile the moth. Add perf moth. Store it in the repository. Let's go back here, refresh the query. And I have a 13th counter. If I go and look at that counter, here I'm seeing all the values that I just put in. An example of another query. Here I'm doing a WQL query. Select all properties from the capacity counter config class, where name equals the name that I passed in the query string. Very easy to add a counter. So if you want to do this programmatically, you can. We should have a UI in the resource kit, and just an example of how easy it is to work with the WMI. So let's jump back to the slides. The third type of events that we work with are health monitor events. Health Monitor is a new product, or essentially a new product from Microsoft. That's a server management tool. It works by collecting WMI data, collecting that data, thresholding against a property return from that WMI class, evaluating the property return against a set threshold. The value is above the threshold, then the rule is violated, and you fire an event. So let me go down and explain exactly what I mean. So the first object are data collectors. This represents the data that you want to collect. Here's an example of the property pane for a perfmon data collector. I'm specifying the object that I want to connect to. Here, the processor object, all of the available counters, and if I'm interested in a specific instance, say processor 0, I would specify it there. Available data collectors include performance counters, event log events, services or processes, complex applications, HTTP requests, and we'll talk a little bit more in detail about those too. FTP, ICMP, which is ping, or SMTP servers, as well as any WMI instance, event query, or data query. Let's take a look at the HTTP data collector. This is one that we think is going to be of particular interest to AppCenter users. It's a really good way to monitor if your web server is working, if the business logic all the way back through to a database is working. Basically, what you do is specify a URL, a timeout. The provider makes that a request to the URL, gets back either an error or a success. You can threshold against any of the properties you return, such as status code, status text, contents of the page, time that it took to get the request back, any HTTP headers, the number of hops, and if the result was not what you expected, so for instance the status code is not 200, then you flag that as an error. You can use authentication, either none, clear text, NTLM, or Kerberos. The data collector supports the top 4 verbs, get, post, head, and trace. We'll also have that configurable so you can put in any verb. It supports SSL. You can specify the post data or any custom HTTP headers. So once you've created a data collector, the next step is to create a monitor or a rule, which is known as a threshold. And a threshold in this release is a comparison of a single property. So here I'm looking at a performance counter. I'm looking at percent processor time. And you can look at current value, average value over a set number of periods, or the change from one period to the next. You can compare with greater than, less than, equals, not equals, greater than or equals, contains, does not contain. So here I'm looking at the current value for percent processor time is greater than a 90 for at least 6 times, then go critical. So I can threshold against a single occurrence or a number of occurrences. This performance counter is being collected every 20 seconds, so 6 times means over 2 minutes. So if my CPU use is greater than 90 for 2 minutes or more, then change to critical. And you can change the state to critical, to warning, reset back to normal, or just fire an informational event. Along with a threshold, you can specify an ID, a message. The message can contain any of the properties returned, such as the name of the data collector, the name of the threshold, the instance, the compare value, the comparison, the current value, time, server, any of the HTTP properties returned in the case of the HTTP provider. So for instance, you could have the contents of the web page included in the message and sent in a mail. And these messages are fired whenever the threshold crosses, or whenever the value of that you're thresholding against crosses. Did I say that right? A WMI event is fired when the threshold is crossed, either going up or coming back down. So if CPU is over 90% for 2 minutes, the rule goes to critical. If it goes back to 50%, the rule will reset back to normal. Actions. Of course, if a threshold is crossed, you probably want to fire an action. And actions can be applied at any node in the tree, at a threshold, at a data collector, at a data group, at groups of data groups, or even up at the system. And you need to think about where you're applying the action depending upon what behavior you want. So say I have a data group that has 2 data collectors, each with 3 rules. If I apply my action to each of those rules and they all go bad, I'm going to get 6 errors or 6 mails. If I apply the rules to the data collectors and they both go bad, I'm going to get 2 mails. If I apply the mail to action to the data group, I'm only going to get a single mail when any of those rules go bad, and get the reset mail when any of them return back to normal. So there's a balance between knowing whenever something goes wrong on your system and potentially being mail bombed with a lot of mails. There is some throttling capability, though, to keep you from getting repeating mails if a rule keeps on being fired, and you can also have reminder mail sent if the rule stays bad for a certain period of time and you have not corrected it. Possible actions include running a command line, sending email, writing to a text log file, writing to the Windows event log, or firing a script, a VB script, J script. In AppCenter, we're going to set up a number of default monitors for you in HealthMon. We're going to set up some synchronized monitors that are replicated to every server in the cluster. We'll set up actions that are also replicated to every server in the cluster if they're associated to a synchronized monitor. We'll create a non-synchronized or local monitors data group, install a number of sample monitors also. Let's talk in detail about these. So on the synchronized monitors, first thing to notice is that data group, the synchronized monitors data group, every child is replicated cluster-wide. Also, that data group cannot be removed. So if you go and delete that group, the next time our replication service runs, it's going to recreate that group. The reason we need to do that is we identified the group by a GUID, not by a name, and we need to ensure that that GUID is always there. We also create a second group that must always be there called the online-offline monitors group. This group has the online-offline action applied to it. You probably heard about this action from Ori earlier. Whenever a monitor in that data group goes up critical, the server is taken offline from a load balancing. Once every monitor returns back to a normal, we call an online action to take the server back online. The status of that data group is also checked before the cluster services start. So if you're rebooting a server, it comes up and there's something wrong, that server will not be taken online. It is possible to force a server online, though, from the command line. Because this is a potentially dangerous data group, we're only shipping a single sample monitor in that group that watches the W3 service or IIS. If the IIS service stops, we take the server offline. When it restarts, we bring it back online. We're also going to set up a number of other default monitors to help you get started. Sample monitors for all the AppCenter services, for the cluster service if the cluster controller cannot be found. For the replication service, that rule goes critical if a replication job fails, returns back to normal the next time a replication job succeeds. If request forwarding fails, and again, if the web service fails. We'll also set up some sample monitors for memory and processor, and a sample HTTP monitor that monitors your home page on the local host. If the page is not available in 60 seconds, it goes to a critical, and the status code is not 200, it goes to a critical. For actions, we're going to set up 3 sample actions. The first is to email the server administrator, and we ask you for this information when creating the cluster. If you need to change it later, you need to change it in HealthMon. And as well as the online and offline actions, and we'll be doing this through an XC. Online XC 0 takes the server offline with a drain time of 10 minutes. Online XC takes it back online. These are the actions that are applied to that online-offline data group. We'll also ship a number of sample monitors for other AppCenter services, for CommPlus, other IIS and ASP monitors, other sample system monitors. We're working with other teams such as Commerce Server and BizTalk to get some samples for them. One other area that we did some work on is on CommPlus to help people manage CommPlus apps. And one of the issues here is there are no performance monitor counters available for CommPlus apps. So it's very hard to know if there's something going wrong with your component. So we wrote a CommPlus statistics provider that we're shipping with Health Monitor. This gives you metrics such as committed transactions, aborted transactions, creations, activations, total shutdowns, timeout, admin failure shutdowns, and object pool timeouts. We're also providing all of the Win32 process statistics, which includes memory used, threads, handles. This is useful because normally this is only going to show up as DLL host. And if you have 10 components running, they're all going to be listed as instances of all with named DLL hosts, and you're never going to be able to know which one to look at if you went straight to WMI. So we've just rolled those statistics up. Very useful tool, but there is a performance hit to doing it. So just make sure that it's something useful. We also did some work to make it possible to monitor databases, and we're thinking about four things here. Did my query run? Was the data what I expected? Is my server alive? And is my server healthy, or is it potentially in need of performance tuning? And this involves monitoring both on the client side and on the server side. On the client side, our focus is really on is my business application working? We do this through the HTTP provider with calling an active server page. This ASP can either be a real ASP in a web app, a special monitoring ASP or component. And we're also shipping a couple of sample ASPs that do a query and dump back all of the, and display back the OLEDB errors if there's a problem doing the query. This is good because it can work with any data source that talks ADO. And when you're monitoring a database, you don't want to take the offline action, because if one server can't reach the database, it may mean that all the servers can't reach the database. So if you start taking servers offline, all of a sudden none of the servers are there. So instead, a recommended action is to redirect users to a different page, saying, sorry, come back later. Let them know that there's a problem, then change a redirection when the database is back up. And we'll be shipping a sample script to do that as well. If you're using SQL Server, we can provide you with a little richer monitoring. This does involve running HealthMon on the database server, though. Let's try this. A couple things that we have access to are performance counters. There is a problem with performance counters on SQL 7 and SQL 6.5, though. So if you do want to monitor SQL 7, make sure that you're using Service Pack 2 or later, and it's fixed in SQL 8.0 as well. We have access to any SQL events stored in the Windows NT event log. You can use SQL Trace to fire events to the Windows log, or by default SQL logs, it's critical errors there. The WMI team is also writing a DMO provider. DMO is SQL's distributed management object, which is their scripting interface for managing the server. They're writing that as a WMI provider, so you can do your configuration through WMI, but it also gives us access to a number of properties such as database size, table size, health. And the one thing you can't do from HealthMon in this release is call any methods on it, but any properties are available. And we'll have samples for all three of those. One issue here is you can't monitor this directly in AppCenter. The monitoring that we show in our UI is specific to the members in the cluster. So you need to either use an ASP to do a cross-machine query, to do a query that checks the health of a monitor or a remote server, and shows that in your AppCenter UI, or just use the Health Monitor console, where you can just list any server, any groups of servers. So let's just show you HealthMon live, and this should be on this machine. Let's just show you that it actually does work. Let's create a new monitor here. Let's just try performance monitor. And okay, so we browse for the object that we want to look at. Let's look at process. Let's choose an instance, a specific process that we want to monitor. Let's see if I can find Win Management. I don't have to specify a counter here. This will be for statistics that are displayed in the console. I don't want to apply any actions here, but I want this checked every 20 seconds. One thing I can do is specify when monitors or thresholds or even actions are applied. This one is running every day. Maybe I only want it running Monday through Friday, and only from, say, 9 a.m. to 5 p.m. So only during the week, during the day. Oh. Yeah. From 5 p.m. to 9 p.m. Let's see what happens if I do. Is it smart? No. Yes, it was smart. So it changed it from 9 a.m. to 5 p.m. For everything except for performance monitors, it's going to create a default threshold for you. For events, does that event exist? For for processes is that process started. But of course, for performance monitors, we can't identify what threshold you want to monitor, so you do need to create these thresholds by hand. But we'll say if the current value for handle count is greater than 100 for 1 minute, then go to critical. And actions, I should have an action, so I'll mail the ACS admin if it goes to critical. You can see here's my rule, and it automatically created the name for me if handle count is equal to 100. It's pretty straightforward. And back to here. So just a couple of issues with HealthMon. One is just going to be setting it up. It's not. You need to understand your system in order to monitor it. We're going to help people out by shipping a number of samples, defaults, documentation. Creating those default rules when you create a data collector. But it really comes down to understanding your system, understanding where your baseline performance is first, and then knowing that you want to be alerted if the system deviates above or below that baseline. And it's also local monitoring on each server. This is both a limitation of HealthMon Now and a scalability choice that we made. So there's no cross-machine queries except over the network, and there's no central monitoring server. The approach that we decided to take is that each server monitors itself and throws exceptions out, rather than having a number of centralized monitoring servers that send remote network probes out to check every server. And it's just not on enterprise console. Going forward, we're starting work now on how we scale this out, how we take more of a tiered approach, and start making this work for large data centers going forward. And just a quick word on security. We use Complus security on all of our components, run them as the cluster user, and all the methods are locked down. Our event provider and WMI namespace is secured to our administrator, our process and cluster administrators. And the health monitor namespace by default is read and remote access to administrators, read-only local access, and all actions must be configured by an administrator, and they all run as local system, and that's a WMI thing. So that's the eventing section. So once you have the events generated, where do you store them? As far as configuration goes, first you have to tell us what events do you want us to store. Do you want eventing on or off? Do you want performance logging on or off? And then what severity events do you want logged? What do you want logged for AppCenter events, Windows events, and Health Monitor events? By default, we're going to log all AppCenter errors and warnings, all HealthMon critical thresholds, and all Windows event log errors. You'll have the ability to exclude events from our view UIs. For instance, you never want to see a front page event. You can exclude that by source and ID, and we won't ever log those to our log. If down the road you decide, well, I really do need to see those, you'll be able to turn those back on. For the logging store, we're using the SQL Runtime 2000, also known as MSDE 8.0. This is a specially tuned version of SQL Server designed to minimize impact on the server in terms of CPU and memory. One of the reasons why we're using MSDE 8.0 is the multiple instance support. We're going to run our log as a named instance, so we can exist side by side with any existing SQL 6.5, 7.0, or 8.0 database on your box. We have our own instance. If you already have a database there, we don't need to touch it when installing. We fully normalize the tables and index things to minimize space and query quickly. We periodically clean up the database to minimize space as well. and we document the schema for archiving. If you want to suck the data out into a data warehouse or central store, you want to build Excel or Access files to build your own reports. For the event log schema, we store all the event instances in the events table, the metadata common to events in the event classes table. There's a server lookup table. Our help messages are in their own table, and there's an event view to make the join easy for you. In that event view, you get back the event ID, event GUID, what time it was generated, any of the data or message, event ID, severity, log, category, subcategory, and all of the messages. This is also the view that we use to build our UI. As far as cleaning up the log, it's done by a stored procedure scheduled by SQL agent. By default, we store events for 14 days. This is configurable in the UI, stored in WMI, and replicated across the cluster. The size of the log really depends upon the number of events received and how much data is passed with those events. The size of each event in the log is 16K plus the size of the data field. We're doing a lot of performance testing on the logging now to really get a better sense of what the size of the logs are, what the transaction logs, what the indexes are, and what the performance is. So we're going to have some better numbers on this closer to beta. The perf log schema, we have a counter ID that has the metadata for each counter that we collect, a table for each of the time intervals. The 10-second interval is in the perf history table, a view for each of those tables. We're also setting up 2 tables for the capacity planning tool that will be in our resource kit. And then the view is giving you the time of the counter, the data, the counter name, all the aggregation methods, scale units, etc. As I said earlier, we store the performance counters as 10-second data and then roll them up in the other tables. So every minute, we roll up the 10-second data to one minute data. Every 15 minutes, that gets rolled up to 15-minute data. Every 2 hours, that gets rolled up to 2-hour data. Every day, that gets rolled up to one-day data. We do all of our roll-ups based to 0. So midnight, 12:01, 12:02, 12:15 to 2 a.m. So all of the data is consistent and normalized across all of the servers. This is also done by a stored procedure scheduled by SQL agent. These time intervals are fixed in this release, and they are tied to the views that we show in the UI and designed to give us the number of points to fit in the UI. However, the storage period will be configurable. The 4 days, 10 days, and 125 days is what we store by default. A number of customers have said that they want to be able to keep that data for a longer. So 4 days is nice to have fine resolution data in case something happened over a long weekend. You're back in the office on a Monday or a Tuesday, but it's valuable to have long-term trend data about what's going on your server. Unfortunately, this is pretty lean. Right now, we're storing about 680K per counter for those periods. That's about 13.5 megabytes for the 20 counters that we're looking at now. Again, we're perf testing this, and we'll have a better idea closer to beta. So how do we roll up these counters from 10 seconds to a minute? Based upon the counter type specified in that MOF MOF file and stored in WMI, we're either going to take an average of the values, the sum, the last value, and we give you the capability to do min or max. So depending upon the counter type, whether it's something like total requests or current errors or errors per second, you specify what math we should do. And most commonly, it's going to be an average value or the last value seen. And for values that are summed up, like growing counters such as total requests, we don't store the growing number. We store the delta, the difference from one period to the next, and then do the math to roll that up. Some people have, or we have heard concern that although what we're doing with a log is great, but you really just do not want MSDE on your server. So we will support a setup mode without MSDE. This will be a custom setup option. It must be consistent across the cluster, and we do a check when a server joins the cluster. Because we don't have a log, we're just going to write our errors directly to the Windows event log, and this is configurable. So if you want to log both errors and warnings, you can, and that can be tweaked on a per server basis. If you're having problems with it with an individual server, there's just no UI for it. It's setting a property in WMI. And the trade-off is, of course, you get no event view or performance view in the UI. And I've been asked the questions, do we support logging to a DSN? The answer is no. We weren't able to guarantee that events would be logged, so that's just something we're not doing. There is an alternative that we're talking to a couple of internal customers about, and that's writing your own event consumer to listen to events. So say you want to log or collect and log subcentrally every AppCenter replication event. You can pretty easily write your own event consumer to listen for those events, then write them out to whatever store you want, whether it's a text log, a database, etc. It's something where, if we have time, we'll do as a resource kit sample to at least do the consumer part for you, have the data available. You then just have to write it out to whatever log store you want. And this is pretty easy to do. This is the extent of the event filter or the event query that we use for AppCenter events. Select star from ACS base, where type equals 4, gives you all of the critical events. For the Windows events, you're saying select star from instance creation event, where target instance is a Win32 NT-log event, and target instance type equals error. And for health mod events, select star from instance modification event, where target instance is a Microsoft HM threshold status, and target instance state equals 9. So this is doing a WMI query for all critical threshold of events. Security-wise, we're running MSDE with integrated security, with access locked down to administrators and system admin and AppCenter administrators. All of our querying is also done with integrated security. It's in the wrong place, but okay. All right, I know where we are. So a slide got moved around, but this takes us actually to the next point. Now that we have all the events generated, the events stored, what do we do with them? How do you see them? Because we store events locally on each server, we had to develop a distributed query architecture to gather all of the events, build them into one record set, and display them in the UI. The way we do that is we of course have the ASP that the UI is talking to, two components that parse the query, do the distributed query, gather the results, and send it back to the UI. And these run on the cluster controller. So you have MSDE on the controller machine, server 2 and server 3. So the UI comes, makes a request to ASP, calls our log query helper component, which parses the query, passes the query to the log query component that runs the query across the cluster, gets the record sets back, passes them back to log query helper, which aggregates and formats the results, and passes them back to the UI. So now let's see what gets passed back to the UI. The first view is the event viewer. This gives you a list of view of all the events on a per server basis or across the entire cluster. It's sorted by date. You're seeing severity, the server name, the source, the event ID, and a description. For AppCenter events, the description is a verbose description of what that event is, what it means. So the source is going to be replication, the ID is the specific replication event, and the description tells you what happened there. For Windows events, the source is the source, the ID is the ID, and description is going to be the event log that it came from, the application security or system log. For health monitor events, the source is the data collector name, the ID is a threshold ID, and the description is the threshold name. You can filter events by log source. So AppCenter events, NT events, HealthMon events, by severity, warnings, errors and warnings are all a specific source and or specific event ID. In the details view, you'll see severity, date, time, server name, again, a description of what the event is, the category, subcategory, a message that will either be the message from the health monitor event, the message that you would see in the NT event log, or a similar message for AppCenter events that say, again, for a replication event, will tell you the actual file that, say, could not have been replicated. We also have links to online help and to support. And these are two of the more innovative features that we're doing. So first is a link to help. So for error and warning events, for AppCenter events, we're going to show you the event ID, let you know what's going on. So giving you detailed troubleshooting information. What was causing the event? How can I solve the error? What are the things to look for? This is really a design for beginning to intermediate users. We also have a link to online support. This is just the sample page that you're seeing here, but for every unique AppCenter event ID, we can either have a general help page or a specific help page for that event. So we're looking at this as a living extension of the product, bringing the product experience to the web. It's something that's being defined by the AppCenter team, being managed by product support, and it's very clearly not a marketing site. So for a specific event or class of events, we can stick on knowledge base articles, facts, known bugs, hot fixes, documentation, tools, links. So it's a pretty cool way. If you're working with the tool, see a problem that you just don't understand, you can first look at the online help. If that doesn't answer your question, go to the support site. And because we can track what error codes people are going to, if a lot of people seem to be having trouble with a specific error, we can look into it more, ask people for their email addresses, have them send us stack traces or dumps from the system, and really start having an ongoing dialogue and really help improve the product. The way we do the cluster of event rollup, as you saw in the diagram, it is in a component on the cluster controller. We're aggregating all of the events from each of the members, sorting them by time, creating a virtual record set. We tag each event with a GUID. So say you do a query, get back 1,000 events from each of the servers. We're not going to send 1,000 events back to the UI at once. We're going to send back 100 at a time. The UI is able to virtually page through that record set. By passing that a GUID, we can scope the query to the next set of records that you want to see, immediately jump down to that record and send the next page back to you. This is one of the reasons why we have to enforce the sorting by time. So we're guaranteed that the events will be returned back in the correct order. However, say you're querying a cluster of 8 and one of the servers is unreachable because of a network problem, we're not going to completely fail. We're going to return back data for the servers that we could reach and just pass back an error in the UI. The performance view, or how you look at the performance counters that we're logging. Here's a view of two counters, processor utilization and available bytes. You could go and add any number of counters. I think we're going to support up to 30, the ability to view up to 32 counters. You can specify the time period that you want to see, 15 minutes, 1 hour, 1 day, 1 week, 3 months. This corresponds directly back to the 5 tables of data that we're storing, and that the time intervals are designed to give you the right number of points in the UI. Because we're pulling data from the database, unlike perfmon, if you bring up the 15-minute view, you're seeing now on the right and seeing data for 15 minutes back, and then that view refreshes every 30 seconds or so. All of the counters are auto-scaling between 0 and 100, so they all fit on the same chart. We do the roll-up here, much like we do with the events, based upon we go and gather points from all of the server based upon the cluster aggregation type. We're either going to take an average value, a sum of value. Last, min, and max don't have as much meaning here, but you could, if you did want to see, say, like what's the min, say you want to look at just memory, you can have 3 counters, one that's looking at min, max, and average value, and see what my average is across the cluster, what the min is, and the max is. So by collecting counters multiple times, you can do different aggregations and roll-ups. For the cumulative counters, things that are like total requests, we reset this back to 0 for each session, for each instance of the UI. This is a little bit different from the way perfmon does it, in that perfmon, if I'm looking at like total web connections, every time IS restarts or starts, that counter drops back down to 0. Because of our aggregation over time, aggregation across the cluster, you would see that total number drop down. So you would start seeing some funny spikes. So instead, we're logging deltas, always summing them up. So this is one difference from perfmon. If this behavior sounds strange to you, once you start seeing it and playing with the product, again, let us know, and we can look at changing it. And the one view that we do not show is one counter across the entire cluster. So if I have 4 servers and I want to look at memory, I can't show you one line for each server on that single counter. Because we only had time to do one, we talked to a number of customers, and everyone said, because I can get the equivalent of that view in perfmon today, or in your per server UI, do the roll-up aggregation view, because no one else offers that now. And finally, the health monitor console. This is MMC only. There is no web UI for this. However, you can monitor multiple servers. So here you see I'm looking at A Sutton Brick 1, A Sutton Brick 2. The rolled-up status on the top, the all monitors computer, represents the worst status of any of the children servers. So this is one way that you could monitor on a single console servers that are both part of an AppCenter cluster and not, so your web servers and your database servers, or multiple AppCenter consoles. Configuration is pretty cool. It's drag and drop between data groups, between servers. So you can cut and paste if you want to move things around. The other view that's kind of handy is the statistics view. So particularly for the performance monitor counters, I can also go to that property page, click the checkboxes for counters that I want to see statistics on. It's kind of a quick and easy way of seeing what, sort of a perfmon view of the current value, as well as min, max, and average for as long as the console has been open. So one caveat here is that these are valid only for that console instance. There's no archiving, no storage in this release of HealthMon. We also give you a couple of views of the HealthMon data in the AppCenter UI. The first is the server health roll-up, which is this little view in either the cluster or the server view. The icon represents the HealthMon status. In the uppercase, unknown status. In the bottom case, good. This is the system status from HealthMon, the overall health of the server, not the online offline group. The other two, the online represents load balancing, and alive represents the heartbeat from the cluster service. We also have a monitoring view in the UI, which is very similar to our event viewer. This query shows you the current status of all your data collectors, and then down below the threshold for that data collector. You have the ability to repoll, to recheck a data collector, and possibly the ability to disable it. This is not a cluster-wide view. It's only a single server view. The cluster-wide view is provided in that previous roll-up. And any configuration needs to be done in the HealthMon console. This is a read-only view. Just a quick word on extensibility. All of our events, all of our data are available to any WMI consumer, either your own, and we're working with all of the console vendors. You can pull data out of the logs, say with the SQL DTS service or the SQL distributed query. Say you want to pull the information out, store it in a data warehouse, and do some long-term trend analysis there, or correlation to statistics on your site. It's also very easy to write your own ASPs or Excel or Access files to either talk to WMI or query our database. And just as an example, I was playing around last night and did a quick one on this machine. So this is going to one of my machines that was running for a couple of hours, pulling out the 1-minute perf data and showing it over 4 hours time. So this is giving you a resolution and more data than you can see in our views. I did this through a pivot table and pivot chart. This is just pulling out the raw data. We do all of our logging in GMT. So if I were to get fancy here, I'd write a function to convert GMT to local time. If I wanted to show more than one counter, this is where the scaling is important. So say I were to add, actually I don't want to do it on this one. Let's go to a different view. This is looking at one of the services running in my office now. Let's refresh the data, see if we get something new, or it's going to fail. Okay, and say I were to go and add another counter like available bytes. So here I'm seeing available bytes, which goes from 10 million to 50 million. Processor utilization is here too, but it's down at 0. So this is where I would want to multiply available bytes by its default scale, 10 to the minus 6. Scale it down so I can see it on the same chart as processor utilization. So again, in the pivot table, it's fairly easy to do. I can just write a function that's going to multiply this by either the default scale that's returned with the counter, or with one that I specify here. So there's some pretty cool things that you can do with our UI, but because of this extensive plumbing and extensibility, the coolest thing are really scripts, ASP pages, spreadsheets like this that allow you to get to exactly the data that you want, do the customization that you need, and just build the right tools for your job and your problems. And let's just jump back to here, and I think that's it. So we got about 20 minutes for questions now, or I'll be around later tonight from 6 to 9, or at the end of the day. So, is it? Question is whether HealthMon will be available outside of AppCenter. Generally, yes. We're going to support a standalone installation of Health Monitor. It's also going to be shipping the next version of Back Office. and we'll possibly be shipping in some other products also. So the question is whether I can monitor multiple servers and multiple clusters. One of the limitations in this release of HealthMon is all of the monitors, like process and service monitors, are local only. You can't do cross-machine WMI queries. So the way you can monitor remote machines is through an ASP. So I would write an ASP that calls WMI and the other server, checks the value of a particular monitor, a monitoring group, or the particular monitor. Based upon that result, would then go to the appropriate state. Yes, so from the console, I can see multiple servers, and all of the servers, the status of those servers do roll up to the top. But each server really represents its own status. It can't really directly include the status of another server. And just one other limitation on the HTTP monitor is, of course, a single query only. We don't support chaining of queries. We don't support correlating multiple properties. So each monitor is a single property. I can't say go critical if this property is bad, this value is bad, or this value is bad. You can sort of do it in an ASP, but you're getting, you're adding in another layer of indirection, because you're then dependent upon ASP and the web server being there, and that's something that we're working on for the next release. Any other questions? Yeah. Okay, so the question is, how can I add perf counters that are not part of the system? There are two issues here. One is how we would log perf counters in AppCenter. The second is how you would monitor them in WMI. As far as AppCenter goes, all you need to do is provide the PDH path to your counter, which is just object name and counter name. So as long as it's registered with the system, we can pick it up. With Health Monitor, it's a little bit different, because they're going through the WMI cooked counter provider, and that provider does not dynamically pick up additional counters. It's configured to pick up we are pre-configuring it out of the box to pick up all Windows 2000 counters, SQL counters, and all the other back office counters. So we're probably going to ship a tool in the resource kit that's a perf counter dredger that'll go and build a MOF of all the perf counters installed on your system. You would then go edit that MOF, compile it into Health Monitor, and then it will be available there. It's kind of a messy workaround, but unfortunately there's no other alternative there, and we will document that probably in the resource kit. I'm just going to write that one down so we can be sure to have it. Okay, any other questions? Yep. Okay, the question is, can I talk more about WMI and SIM? A little bit. I'm not an expert on how we're working in the standards body, but essentially, WMI is the Windows reference implementation of SIM. It's based upon the SIM standards, the SIM data structure, and the SIM classes, but it implements and extends that. So things like the Win32 process are proprietary classes. They're not part of the SIM model. They inherit from the appropriate SIM structures, but there's no there's no concept of a lot of our specific Windows things as part of SIM. If I go and look at like the disk drive classes, the 132 disk drive class inherits from the SIM class, so we support both the standard SIM properties as well as extended Windows properties. For things like AppCenter, there's no DMTF standard for what data applications publish yet, and for SQL Server, there's no standard for information that databases should publish yet. So what we're doing there is sort of a first cut at it. I know that the standards people in the WMI group are specifically working on some of the app standards, or app in terms of SQL Server, and we're particularly interested in AppCenter on, if we're thinking about instrumenting middleware apps going forward, what standard information should applications or components make available? So it's something we're very interested in at this point from a design point of view and looking going forward. If you want to make sure that web applications are easily monitorable both from our tools and industry standard tools, what information do they need to expose? So that's an area that we're working on now. So if you're going back to a SIM, what we do should be available through any standard tool that speaks SIM. If there's more information that you need or that's available, it's provided through the extension classes. And through SIM inheritance, the proprietary classes inherit from the standard classes, or not inherit, derive from the standard classes. Does that answer your question more or less? Any other questions? No? Okay.
Get my mic set up here. All right, at this point, we do have some refreshments outside. Why don't we take a break for a few minutes, and then we'll come back in and talk about replication.